So if you guys if you want to speak, feel free to speak. It would be much more fun if you actually intervene, or instead of me just like saying, doing a workshop as if there's actually no one. So we're joined by my twin, who has the same name, Marc Sednaoui. What a coincidence. We're joined by Saif. We're joined by a few others as well. I cannot see your name because I'm sharing my screen. So once we're ready to go live, let us know who's there, and I'll start the presentation.
We're live
Yes,
now.
we're live. Okay, perfect. Okay, so without further ado, this is I'm Mark, and I'm co-founder of Candide, and this workshop is gonna be actually focusing on teaching how to build smart wallets. So I'll go through a quick introduction of account abstraction in general on Ethereum ERC-47. There's maybe like 11 slides. I go through them quite quickly. And then it's actually going to be very hands-on. I'll run through examples. I'll show you how to um, create a smart wallet. I'll show you how to fund it. I'll show you how to sponsor gas, so users don't have to care about paying gas in ERC in ETH or the native token. And we'll show batch transactions, which is a kind of an exciting feature, but without repeating too much, I'll get started. Okay, so let's start with the basics, like Ethereum account, like original or still the main dominant account, is the EOA account, which translates to externally owned account. What does it mean? It means that the account is always coupled with the signer. So if you have a private key, you automatically have a public key associated with it, and that public key is actually your account address. It's secured by ECDSA, which is the cryptography that secures this type of account, and they're always like linked together. So if you lose that private key, then you lose your account, which is devastating because this doesn't happen in the real world. If you lose your, I don't know, Facebook password, then it's fine. You have some recovery method with email. It's not the end of the world. If you lose your bank account password, it's not the end of the world. But with EOA accounts, if you lose the seed phrase, then it's over because they're always linked to the account. An EOA account has to pay its own fees. Like, if you ever use MetaMask, you have to have the native token of the network that you're interacting with. So if you're doing a transaction on Ethereum, you need ETH. If you're doing a transaction, let's say on a network that doesn't have Polygon, you need Matic. And it's kind of, it's kind of, it is challenging. So users don't really understand. Like if I want to just use USDC, why do I need ETH? It's complicated. And then the EOA account can only do one transaction at a time. That means that if you want to do complex transactions, then you cannot think of the Uniswap swap. You always need to approve and then submit this transaction approval and then swap, which is a two-click. If you're the first time Uniswap user, you will never understand what's going on. You're actually going to say, oh, I actually just submitted transaction. Why didn't my swap go through? So that's the limitation of EOA accounts. But now here comes smart accounts. Smart accounts are different. They're actually smart contracts, meaning that we can have logic inside these smart contracts. And instead of a signer being coupled with the public key like before, we have the account decoupled from the signer. So that means that you can have, if you lose your signer, which is a private key, then it doesn't have to be that you lost everything. You lost your main account. You can have some logic to recover it. Similar to regular, I don't know, Facebook or bank account, you always have some recovery option. With smart accounts, you can do the same. How cool is that? You don't need to have ETH in your balance to actually make a transaction. That's actually a breakthrough because you can start using Ethereum without having any ETH. You can just use it with, let's say, USDC. If there's someone, if you use, we're gonna go through paymasters soon. But if the wallet supports a paymaster, then they can either tell you, hey, will let you pay gas in USDC and will take care of like paying the gas for you in ETH later on, or they can completely sponsor the gas for you. It's like on Optimism, it's like subcents. So that way, I'll promote my wallet to users on Optimism. I'll sponsor their gas for free, so that they can download my wallet and they don't need to do any complicated like keep an ETH balance if they don't need to hold ETH. And then lastly, smart accounts can sign once and execute multiple. So think of the last Uniswap example that we just like mentioned. You can actually do approve and deposit on the same transaction, and that is actually intuitive for the user, and it's just a one trick. You can do much more complex stuff, but like that's the basic like flow in any let's say DeFi interactions. Actually need to approve the ERC20 spending and then interact with the dApp contract. Quickly over what. So what can we like? We mentioned like a few of these features in smart accounts. So you can have sponsored gas. We talked about this. Like let's say let the user pay an ERC20 token or sponsoring gas. We talked about different signature schemes. So you can make hardware. You can make the phone as a hardware wallet. So you can use the same cryptography of like the phone to actually validate transactions instead of using the normal private or public key that there's always like the default on Ethereum. And then you can have like some cool logic in the app. So you know we don't have subscriptions on Ethereum because of the limitation, but you can have a smart account subscriptions built in, and that way you have some apps like Spotify, and you can charge a subscription fee on that. Quickly going through the account abstraction components. So the way they work is that you have 4 kind of components that we will talk about. Some of them you just need to know on a high level. Some of them you need to know how they work a bit. But mostly, if you're building a smart wallet, you actually only need to take care of the account, and all the rest is actually by developers who spend countless and countless of hours building these 3, and you can leverage them already. So the account is the smart contract. Usually, if you're a smart developer, you'll choose an account that is already developed because there's quite good smart contract accounts. I can mention Safe. This is the one Candide recommends, but there's also great smart contracts accounts like Zero Dev. They also get they have a good smart contract account. I can think of Economy. They also have a smart account. So all these like they are already developed. It's a Solidity contract. It's already developed, and you can reuse them to offer your users their smart account based on these contracts. You don't have to reinvent the wheel unless you're doing something very innovative and you want to maybe be creative a bit. Then you need to work on some Solidity to develop the account. The account needs to be compatible with the entry point. This is the main contract that 47 team has developed. This is the one that orchestrates all these 1, 3, and 4 to work together. You don't need to be an expert in the entry point contract. It's already developed, and you can take a look at how it works on 47 EIP, and you'll see all the details of how it works. This is not the topic of our conversation, but all you need to do is actually understand what's a user operation. This is the type of transaction that smart wallets send. It's like a normal transaction, except it has like some fields that are typical to smart wallets, like paymaster, which is the one that is responsible for paying gas, and then extra like gas stuff. But in general, all you need to know is these. Once you get familiar with these, then you pretty much have a good high-level understanding of the entry point contract and what it needs so that you can send your user operation. A bundler, you can consider it as the node. So if you know, like Alchemy or Infura, they provide node endpoints for normal transactions, but smart wallet needs an extra type of software called bundler. It does accept user operations, and this is the software that you need, similar to a node, and it's provided also by a few entities that also provide bundler endpoints. By the way, Candide gives you everything. So we'll go through this at the end with a hands-on workshop. And then lastly is the paymaster. This is the entity that is responsible for paying gas. So if you want to sponsor gas for users or letting them pay in ERC20 token, it's actually a separate entity from the one executing the transaction, like the bundler. So they're actually separate. You just need to take this into mind. Is there any questions so far before we go through the next half of the presentation? Cannot see the chats. Let's see chat. Nope, no chats. And chat is
Wait, so
disabled. Okay,
yeah, I think the chat is disabled. Let me enable it.
sure. Is there any questions on YouTube as well?
Not that I can see, sorry.
All right, if anyone wants to speak, just like you can unmute. I hope you have the ability to do so. And if not, you can chat if you're shy, and then we'll take it next. Okay, so how are things work? So if you get the high level flow, okay, you build an app. That app, let's say you build it through this type of very fancy security. So it uses the authentication of the phone. This is a standard called WebAuthn. It uses Touch ID to verify transactions on chain. So you build your app, the user, and then you send the user operation. You constructed, you did it well, and then you send it to the node, which is the bundler. The bundler receives the user operation, and it executes it. So what happens on chain is that the entry point contracts verify the signature. Is this the real owner of the account? And then it verifies that if there's a paymaster, it verifies the stake of the paymaster. And then if everything is good, then it validates the paymaster. And then it executes the operation. And then number 5 is the post operation. If there's like any leftover, sometimes let's say the paymaster, I don't know, we took a little bit more than it should be for the gas, then there's like a leftover that is returned to the user in their post operation. So this is number 5. So that's like a high level of what's going on. It's not too complex. You just need to know like okay, this is what happens. You send the user operation, bundler executes it, and this is what happens on chain. You don't need to know like exactly what's going on here. You just need to know that it actually happens because we're not the developers of the entry point contracts. They are people who developed the standards. They already developed it and it's audited. So you can rest assured then it's that you can use it. So what happens in the app? The app constructs user operation, the user signs it, and then submits the user operation. So this is what happens in the app. Now, how do you actually use an account? So if you have your own contract account, you can use it. Candide, we recommend safe account, and we develop like a library. You can use it. We'll actually go through examples quickly through this. Is there anyone? Nope. So you can use abstraction kit. It makes your life much easier. You have safe accounts to offer to your users. You have a lot of features like account recovery. You have passkeys. You have gas sponsoring and so forth. So if you don't need to, if you would like to use safe accounts, I didn't mention what is safe quickly. So safe, it's famous for the wallet for companies. Or DAOs or enterprises because it allows multiple people to hold ownership to the same account. But it's much more than a multi-signature account. So you can actually make it programmable so that you can offer it to your users. And why is it famous? It's just like it's battle tested. There's $100 billion asset stored. It's been developed for over years, and there haven't been any security risks, and people actually trust this account. It's audited, so you have it literally for free to use. So
Mark, sorry.
yes, go ahead.
Could you just remove the lines craft on the top right I think you can just minimize it so you don't see me.
Oh, sorry. Is
Yeah,
that better?
perfect. Yeah.
Okay, next slide. Okay, so we're going through the components. So we mentioned the app, which is this is the main thing that as a smart wallet developer, you're going to actually be responsible to the design, the interface. You're going to integrate a library. You can choose abstraction kit. You can choose another. You can choose another type of accounts. And then you'll actually would like to, this is one of the main benefits of smart wallets is that you'd want to sponsor gas for users. So you'll use a paymaster. You can offer two modes. So either sponsor gas policies, so someone is actually paying for the whole gas, or you can use you can pay gas in ERC20 tokens. So that's the main benefits of paymasters, and Candide also have a paymaster. We'll go through it as well in a hands-on workshop. And then lastly, a bonder. Bonder, this is the most this is the nodes. So if you like Ethereum, bonders have different client implementation to make the system robust. So if there's a bug in the language of one of these bonders, then you can switch to another easily. It's very standardized. You just switch it with a link, similar to switching to a node. It's quite simple. At Candide, we developed Voltaire, which is built in Python and Rust. But you also have like maybe 10 over bonders. You can switch or have it also ready to use. And they're supposed to work in a mempool. The mempool is being developed so that you'll have essentially once you submit the user operation, the bonder who's able to accept the user operation with the best price, with the best execution, they will take it, and it's going to be very competitive. And that's why we have multiple bonder implementation. At the moment, it's actually working in a private mode. So if we're gonna go to this link here, we're gonna get a link to Candide's bonder. Actually, it's not here. It's actually here. RPC endpoint. And once you submit the user operation, Candide is gonna take care of it. But in the future, the system is very decentralized. Is that there's it's gonna be similar to a network where everyone is competing to get the best execution for the user and the best prices. That's it. That's an overall account abstraction in general. So I took like maybe a little bit over 50 minutes to present it, but I want to take the rest of the workshop. We have around 45 minutes to get hands-on to actually build the wallet. So if there's actually, is there questions before we go dive into the second part? I cannot, chat, here you go. Which bonder do you recommend using? Of course, I recommend using Voltaire, which is our bonder, without being any biased. But so there's no recommendation in general. If you'd like to see which all bonders I can, so I'll give you an honest opinion. You'll go to the official 47 website. You'll have a link called the bonders. And then once you open this, you're actually going to see all the bonders that pass the latest like standard test. So we actually have 1, 2, 3, 4, 5, 6, 7, 8 bonders that pass the tests. Some actually are passing with most of them actually like passes like most of the tests. So all these are in good shape. So Voltaire is only missing 6 tests. Alto is only missing 9. Ronder is missing 19. This is the Alchemy bonder. Silas, it's a small team, is also building a great bonder, missing 9. So these are, it gives you an idea of how bonders are going through the development and keeping up with the standard. And if you want to see, let's say, who's the, which ones like are fast or like in execution, you can go to the results and then actually take a look at the results here. Are we going to see it here? Yes. If you go to actions, and you'll see build test results. Is it going to be here? Run over up. Yeah, and then is there test results here? Oh, here you go. Test summary. Okay, so this gives you how much time it took for each bonder to pass all tests. So Voltaire, it failed 6, it passed 165, had one warning, and it passed all in 1 minute and 53 seconds. The next one, AA Bonder, which is the reference bonder, it took 4 minutes, and so 4 minutes and 25 seconds. That's double the time of Voltaire. The next one, Alto, 4 minutes, 4 minutes, 4 minutes. Ronder seems like the closest to Voltaire at 2 minutes. So this gives you a little bit of also the speed of how bonders are executing. So that's a good reference for you as well. Does that answer your question? I guess so. Is there more question on YouTube? I don't know. Is there?
No, there are no questions yet. There
All right.
are a few viewers there though.
All right, sounds good. So if we are ready, we can go on the workshop. So I'm actually gonna do something very fun. I'm actually gonna assume that I don't have anything, and I'm just gonna go through the doc, and we'll do it. I didn't prepare anything. Like I mean, I did prepare what I'm going to do, but I didn't prepare like the code base. So we'll do it all from scratch. So to give you an idea, let's first start with what is a smart wallet as a demo quickly. If you go to, I'll actually demo our passkey example, which is pretty cool. So I went to our website, and there's a button called Try Passkeys Demo. It's on passkeys.candide.dev. And here I actually have an account address that is secured by passkeys. And passkeys is used pretty much on every device. If you're using an iPhone, it's going to use Touch ID. If you're using Android, it's going to use the biometrics of the phone. And if you're using a Linux, which is quite a unique case, like mine, and I'm using a Dell, then I actually don't have an authentication method by default, but I can use a password manager. So I'll actually enable my password manager here. So is it Bitwarden, for example? And Bitwarden supports passkeys. All password managers today like supports passkeys. And I'll try to mint NFT, and I know this account is actually secured by my password manager, and the passkeys is over there. And here you go. So I'm actually going to type my master password. Obviously, this is not a real password manager, so I wouldn't let you see it. And you cannot see it as well, so that's good. So type it in. All right, and it recognized that I'm on passkeys.candide.dev, and it says, "Hey, do you want to log into your account?" I'll say confirm, and here you go. I actually just minted an NFT without using any seed phrases, without using any complicated stuff, and I can go and track it on Sepolia. So let's see if it's gonna track it. All right, if you just go here, up. Oh, here you go. So we just minted an NFT. It didn't take us anything complicated. And I just showed you an example with a Linux, so you can expect a much better experience on iPhone, on Android, or like MacBook, and so forth. Okay, so now that you actually see what's a smart wallet, let's actually build one. So I'll go through our documentation. And let's start a new terminal. So if you want to follow along, you can, but just let me know if you need some time to code with me. We can pause and come back quickly. So I'm gonna actually demo Abstraction Kit, which is the way you can, which is a TypeScript library. It helps you construct user operation quite easily. It has safe accounts built in. It has the bundler class, it has the paymaster class, and so forth. So we'll demo the very first like getting started example, and let's create a new project from scratch. All right. So this pretty much guide, it tells you how to send the user operation. That's pretty much it. Like it does deploy a smart wallet for the user, and it mints an NFT. And that's it. No paymaster, no passkeys, no complicated stuff until we get started like from scratch. So
Mark, sorry.
yeah.
There's just a question in the chat.
Okay, yeah. Can you send the docs link? Yes, for sure. Here we go. So this is the one we're gonna do. Is there a question in YouTube as well or no?
You just send this in the YouTube chat as well.
Yeah, can you send it for me, please? All right. Okay, so essentially we'll get set up. So now we'll create, let's say, create a new project here. I'll go to, let's see where, I'll go to my documents and I'll do make, I call it save batch mint. Sure, let's call it the same thing. All right. So, and then let's navigate to save batch mint and we have an empty project. Now let's install abstraction kit. So I have a surprise. So the entry point gets upgrades every now and then. It just had a new upgrade to entry point V7, which we released just today. So I'm actually going to go through this. We might expect some errors, but I actually would like to do it so that you can see if there's errors, how I debug them, what's wrong and what's not. So I'll go to the npm package. And this is, and I'll take a look at the versions of abstraction kit. And see here, this is the latest stable version, 0.1.13. The last experimental one was 0.1.12, and the one we just released is 0.1.14. So I'm actually gonna use this one for today's demo. Yes. So I'm actually gonna add, gonna do yarn add. But I think I need to do npm init first, but let's see. Yeah, it actually created automatically. Okay, so here we go. I made my first mistake. I actually installed abstraction kit, not the version that I wanted. Let's go to the code and see. Okay, I actually wanted 0.1.14. So let's do this otherwise. Abstraction kit. All right. Now, yeah, it did default to the default one, not the experimental one. Did I close it? All right, now we are at 14. Okay. So we might want to also install a few other libraries, but let's take it from there first. So we'll create an empty file called, we'll do source. We'll do a folder first called source, and we'll create an empty file here to run our scripts. And let's do a TypeScript, not JavaScript. Right. And actually, in this step, we actually have to create the environmental variables. So we'll do create and do this. And then we'll copy this. And then these are my environmental variables. So this is the Sepolia chain. And this is the bundler endpoints. We need the node Sepolia as well. And we need a private and a public, private key and a public key. So that's quite easy to get. Do we have questions? Nope, we're good. So let's go to chain lists. This is a website where it actually gives you a lot of test endpoints. It's pretty good. I'll search for Sepolia. Okay, it's not showing up. Why? All right. Let's do something smarter. Sepolia. Where is each Sepolia? Okay, the website is not as good in filtering. Okay, let's do otherwise. Let's go to Infura and get an endpoint from there. So the reason why we actually need a node, because it does fetch some information on the blockchain that we need. Let's say it gets the nonce, it reads the balance of the wallet. But most importantly, it does read the nonce for the account so that you can know which nonce you can execute for the user operation, because that's a field that is important. And if you don't know the nonce, which is the order, or a random number actually, of each user operation, then you will not be able to submit user operation. So that's why we need a node endpoint. Okay, until I'm logged in, it's actually giving me a lot of headache to verify that I'm a human, even though I'm being verified by robots. And next up, yeah, let's get a new private and public key. So generally, you could generate it on MetaMask. I usually like to go to just like random Ethereum private keys, and then you're actually going to see it here. I'll just copy one Ethereum public address right here. So don't use any real ones in general. Just use like in your development, just use ones that are you're not going to put real funds in it. And I'm actually sharing it here. I hope no one's going to put any real funds in. All right, now we have the ENV variable filled in, and then let's fill our main index. Here we go. Now we can get the endpoint as well. So let's do let's take one. Let's take this one. Seems like a demo. And I need Sepolia, and I don't know their endpoints, so I'll take this one. Okay, Infura has broken ducks. No, here we go. Quick start. Here we go. I think it's going to be called Sepolia, but supported network. There we go, Sepolia, and then API key. So all these things take a little bit of time, unlike getting set up quickly, but I just want to show you everything from scratch so you know what's going on. All right. Now let's go to the next step, and then now we'll just create an empty function on the index. This empty function is going to execute our code right here. All right, now let's get to the real smart wallet stuff. The first thing you'll actually want to do is actually tell the user, hey, you actually have an address. So what we do is that we're gonna import the safe account class that we have in abstraction kit, and we're gonna calculate the address from giving the owner public address that we just copied. No one actually asked why do we need a private and public key? So they're gonna be the actual owner of the safe accounts. You'll see later on with passkeys, you don't need a private and public key, but with a normal safe account, you need one owner, and that owner is actually our public and private key. Now we're gonna do import safe account. Do we have v3? Let's see. We don't have v3, which is interesting because I did download 14. Okay, let's keep it with v2. It's fine. And then this library .env, we forgot to install it, so let's install it. Yarn adds. So this one is just a library so that you're able to use environmental variables in your document. This is another file, it's confusing it. Here you go. And then we'll do import .env from .env. All right. So I'll do. So the reason why I do import safe. So this is version 2. It actually works with the old Inshipment contract.
Hey, Mark.
Yes.
Sorry, there's a question in the chat.
Why did you decide to build the AI on top of safe solution? Some other solutions also use safe solution. So like I mentioned, so safe is a very robust smart wallet or smart contracts. They have been in the space for around more than 6 years now. They're securing $100 billion in assets, and it's also what they call battle tested, meaning that with time, it actually proved that it's very secure. You can build programmable things with it, and you can trust that the code that you're going to be distributing to your users is very safe, like their name, safe. It's, however, maybe less innovative than the other new smart contracts that are accounts that are being developed today, because they leverage the newest like ideas for developers. They have very cool features or plugins that you can enable, maybe a little bit more gas efficient. So if you're aiming for very, very innovative, there's features that you can do. You can choose other smart accounts. If you're aiming for security as your number one priority, some of the most used features like account recovery, passkeys, you can use with Safe. So that's why we recommend Safe in general, because it has been battle tested, and there's millions or actually billions secured in the account. All right, so now that I copied the code, what the code is actually doing here, I'm actually getting the owner public address from my EVM, and I'm initializing the Safe Smart account with the owner public address. So with this, everything, I can run this code actually offline. Notice there's no nodes, there's no bundler endpoint, there's no pass-through. There's just pure calculation that this library is doing for you, so you can calculate a smart account address before actually deploying it. So let's try to actually run this before we do anything else. So I'll do yarn build. So I'll build the no license. So yarn build. Do I actually need a license? No, right? Error build not found. Okay, we actually have to have a command for the yarn. I think what we missed is that you actually need to initialize the account. Let's do something init, package name, version, description, up. Is this okay? Yes. Okay, now we have some scripts. And this is what we missed, I think. Let's try again. Do we need to have a script built? I think so. So if you actually are having trouble with any of these, there's always like something to go through. We actually provided a GitHub repo, and you can fork it, and literally you can have it over there. So let's go see the standard example. And what are we missing in the package JSON? We're probably missing some scripts. Yeah, here you go. I just copy this, and then we should be good. Up. Yes. Okay. Yarn. And we actually want that section to 14. Let's do it again. All right, Ryan Bird. I think all right, we have it. We still have some errors. What are the errors? TypeScript compiler version. Okay, we're having trouble with TypeScript. Do you have a question set? All right. Oh, it's actually Mark who asked, which is funny. All right, so what we can do is that if I don't want to spend too much time like having errors with TypeScript, so what I can do is actually gonna fork the standard code so that we don't have we need that okay, we need the TS config as well. Okay, I totally forgot about all this. Let's do this as well. First, yes, config and the JSON. Okay. And then are we missing anything else? I don't think so. Let's try again. Build. Looks like it working. Perfect. We build our code. And now all it's gonna do is actually gonna calculate the smart account address. So I'm gonna execute the script node, and then you notice the folder distribution. So account address, this is our smart account address. Tara. That's the first step. And you notice it's quite fast because it's actually happening offline, just like the calculation. And this is the address you use to display to the user. Notice it's different from the public address. This is the safe address, smart wallet. This is the owner address. So this we do not show to the user. This one we showed actually to the user because this is their main account. All right, let's go back. Thanks a lot for the example. And that was a reference, so we got started. Now that we generated, we got the account address. Now, since we're not going to use a paymaster, we need to fund it with some Sepolia ETH so we can execute the next transaction. So let's do this right away. I'll copy the address that we got, and I'll fund it with some Sepolia ETH. All right, I do have some Sepolia ETH. Is this Sepolia? I think so. All right, let's fund it some Sepolia ETH. I copied the address, and I'll put in, I'll send in, let's say, are we going to be generous? 0.05. Yeah, I think should be enough to deploy the account and mint the NFT that we're gonna do. All right, now that we funded the account, I can let it send the transaction. Now let's go to the next step, step number 3. Now you actually want to generate the call data, which is what the user is gonna actually like do. So we're gonna make it so that it actually mints an NFT, just a random NFT. So we're gonna do this. We have an abstraction kit concept called meta transaction, and meta transaction is the type of transaction that Safe uses. So we call it a transaction, and it's quite simple. It takes the two, which is the contract address that you're going to be doing, the value. So if you're going to be sending ETH, then this is the value. If there's no ETH transfer, then it's going to be 0. And this is the data, which is the mint function that we're going to be constructing here. So let's copy this. So if you already submitted a transaction before, then this should be somehow familiar to you. Up. Now, get function selector is actually a function that helps you get the selector of the function, which is the mint. This is the NFT contract. And create call data is a function that helps you create a call data, like says. You give it the selector, you give it the input, which is the address, and where it's going to be minting. We're going to be minting to the same smart wallet, but you can mint it to anyone else, right? But we'll mint it to the same like account. So remember, smart account, that account address is our safe address. Now, meta transaction is a type. It helps us like be properly like constructing this. And now we have our two. And notice we're doing two transactions in a single one. So we're going to actually do it twice, 1 and 2. And you'll show you how to do batch transactions in a bit. Now, the step number 4 and the one before the last one, we're actually going to create the user operation. So what's going on here? So we're going to call the smart account class that we created, and we're going to call the function create user operation. So what is going to take is going to take the 2 meta transactions that we gave it. It could be 1, it could be 5, it's up to you. And then we're going to give it the node so that it fetches the nonce for you. And we're going to give it the bundle URL so that it estimates the gas. So this is the most important part. And then the rest is just like filling in what we had already on the ENV. This one is to calculate how much it's going to cost. So you can tell the user, hey, this is going to cost this much. And then let's copy this. And then we need to import this function as well to calculate the cost. And then we can run this example actually before submitting the transaction. We're just calculating, and we'll show you how the user operation is looking, how it looks. All right, we need to do a yarn build again and run the code. All right, so here's our address again. And this is how the user operation looks. If you remember from the standard, it has a sender, has a nonce 0. Init code is going to be auto-filled if the account is not deployed. But if it's deployed, it's going to be 0x. But if it's not deployed, it's going to be calculated for you. This is the call data, which has the minting of the two NFTs. These are the gas cost that was calculated by the bundler. And these are the gas prices that are calculated by the nodes. Now, the last 2 fields, paymaster, we're not using a paymaster, so it's 0. Signature, we haven't signed yet. So this is just like a dummy field to fill in, but there's no signature yet by the user. And this is how much it's going to cost in Wei. I cannot read this number, but likely you'll have to divide it by 10 to the power 18 if I didn't see any mistakes. So we need to fund this account, which we already did, to execute this transaction. All right, now for the last step, we need to sign and submit this transaction. So it's quite straightforward. We're going to replace the signature with the user signing. So we're going to include the private key here, the user operation, and the chain ID. Because you don't want to sign on mainnet, you're actually using Sequoia. So we need to sign over the network as well. Here we go. We're fetching the chain ID from the ENV. We're fetching the private key. And then here we go with signing. And then the last step, we're actually going to just submit the user operation. So this is the part where you send it to the node, or what we call the bundler in account abstraction world. And then the last step is to track it. So once you send it, we'll track if it's success or not. So we'll also include this part. So smart account that send user operation, takes user operation and bundler. And then here we have the tracking. And if we did everything correctly, we should have a results like the following: the user operation, and we have 2 NFTs minted. So before I actually submit this code, let's go to the chain actually, and then see our address. And I'll show you how it looks before and after. So this is the account that we calculated as going to be the safe account based of the owner public key. And we are going to Etherscan, but we can use any other explorer. Seems like everyone is trying to verify me today for some reason. Maybe because I'm using VPN. All right, so we deposited this much ETH into the account, but other than this, it's actually a normal, looks like a normal account, right? There's no contract, there's no nothing. And who sent me, there's no token transfers, okay? So that's it. Once I actually hit send transaction, what's gonna happen is that actually gonna deploy a smart account that is secured by the private key that I have. And it's also gonna mint these two NFTs all in a single transaction. How cool is that? So let's try it out. And we're gonna see the changes here on Etherscan. So let's build and run the code again and see if it's gonna work. I hope. Let's cross our fingers. So we're printing the account address again. This is the user operation unsigned. Now it's actually signed it. He's funded. We funded already. User operation sent. We actually did something correct. So let's see where it's going to be. So now it got sent, and we're waiting for it to be included on chain. Usually it should be fast, but maybe we're using an old funder endpoint. We can use the newest one. This is a secret between me and you. We have something called the test, which gives you the latest versions of Voltaire, and it's much faster, this one. Here we go. So now we executed the transaction. What happens? What happens? So user operation received. Here's the user operation have. Which entry point version? We actually use the old one. I did promise we're gonna use the new one, but I'll show you how to switch quickly after I explain all this. This is the sender account. The nonce is 0. There's no paymaster involved. The actual cost, so we had an estimate, but the actual cost is always like less. So that's why it gives you an actual cost and all the information related to the user operation. And you usually are familiar with the transaction hash. So let's go and see it on chain. If I refresh this page, we're gonna find it directly. Here we go. So what's interesting is that here you see contracts. So notice it's a safe contract, safe proxy, and it's verified, and so you can see all the code. And there's NFT transfers in it, and there's two NFTs that got minted, all in the same transaction hash. If you notice, 0xD44, it's the same, and it's the same that we got here. Yeah, I just pasted the one that we got from the terminal. And let's see the transaction. It's usually user operation. You're always going to see it in internal transaction on Etherscan. It's not going to be shown in the regular transaction tab. And that's it. We actually deployed a safe, minted two NFTs, and we created a smart wallet. So that's if we went through this step, then you have pretty much 80% of understanding how account abstraction work, and then the rest are like quite good features that you can add. We have 6 minutes. I can show you quickly how to sponsor gas, but for passkeys, maybe we can do another workshop because it can get a little bit more complex. Example on Ethereum, we have a question, but we can do this on Avalanche or Intersect network too. How different? So yes, the example is on Sepolia network, which is a testnet of Ethereum. Avalanche is an EVM chain, so they do respect everything that is related to the Ethereum virtual machine, so it should work as expected. Intersect network, we don't have information yet on if it's live or not. They did announce that they're gonna start working on it, but I don't think we have information on if there's nodes running or other than this. It's live. Okay, so we can if there's information on how to access the Intersect network, then we can see how we can manage to have it work with account abstraction. As long as if it's EVM chain, then account abstraction is EVM compatible. Okay, so we have 5 minutes. let me I can go through how to do it with a paymaster actually quite quickly, and then we can answer a few questions later on. So if you want to use a paymaster, you actually have an extra step. Just fill in this paymaster and data field. Let's do something. Let's do send a gasless transaction. So this is what you would like to show to the user. You're actually not gonna be paying gas. This is an example of optimism, but like it doesn't matter. It's gonna be any network. And this is what we want to show to the user, free for you. So let's go to step 5. You'll import Candide Paymaster. Now we're gonna take this link here. It's actually ready on Sepolia, and we're gonna have it in our EVM file right here, Paymaster RPC. And this RPC gives you access to gas policies on Sepolia, and we'll import the Candide Paymaster right here in abstraction kit. And we'll just include, instead, you remember, we can always modify the user operation object. So now before signing in, we actually would like to, before signing, yes, let's just call the paymaster class and then do paymaster.create paymaster user operation. It takes a user operation and the boundary URL to calculate the gas. And now you have a paymaster field inside the user operation. And that's it. It's actually the only step that is extra to sponsor gas. So I told you it's quite easy. Once we do the getting started field, you can add as many features as you want. So let's try it out. So notice here, our account, we funded it with 0.05. We used the balance of the account to submit the last transaction, right? We used like around, I don't know, the rest of 0.223 ETH around that. But now let's run this code again, but with the paymaster and see what's gonna happen. Oh, we didn't save. Ah, no. Save. All right, save, and then let's build again. So you'll notice that the balance is gonna be the same because the account is not gonna be paying for this transaction, but it's still up. We have an error. Great. AA31 paymaster deposit too low. So it's actually not an error that you can fix, but it is an error that it could be that the paymaster on Sepolia of Candide needs to be funded on Sepolia. So what I will do is that we can, I cannot like fund it right now directly, but we can replace the network and try it with a different network. But to understand the errors, so there's AA31, which is the error code. And if you're not familiar with any error code, then you can go to the docs here, search for the error code. There's actually very standard error code. Here you go. AA31 paymaster deposit too low. The paymaster is out of funds. More gas tokens must be deposited into the entry point for the paymaster. This is usually done by calling the paymaster contract deposit function. If you're using Candide Paymaster, let us know. Exactly. So I need to call the team and tell them, hey, our deposit on Sepolia is quite low, running low. We need to add more funds to it. And these are all the errors. AA is like account abstraction, and then this is the code number. So it's quite good for debugging. So you need to be familiar with these. All right. I would like to still show you the gas transaction, but let me. We're gonna take some time to switch the chains. So let's answer questions first, and then we can. I'll show it to you. Is there any questions on YouTube or on the Zoom? I don't see any.
No, there are no questions on YouTube.
Okay, the YouTube audience is not very interactive. Too bad. I like the Zoom people who joined on Zoom. Okay. So if okay, let me remember then. How can we sponsor gas? So if we cannot use the Sepolia Paymaster gas list, then let's do this. Let's pay the gas in ERC20 token, and then we'll add funds for the Paymaster and Candide, and then I'll update on the Discord. If you're not on our Discord, you can join directly, and I'll update you once it's done so you can try it yourself. So we'll try something else. We'll offer the users to pay gas in a different token. So that should work. Let's try it out. So quickly, what's happening is that you can propose to the user to pay the gas, and it's different. It's called create token paymaster user operation, and you give it the token address, and that's it. That's the only part that you actually need to replace. So let's try it out. So instead of create paymaster, we're going to do create token paymaster user operation, and this one actually takes the smart account class. It takes what's nice about TypeScript is I don't even need to remember, even if it's my own thing. Smart account, user operation, bundle RPC, and that's it. And the rest is like optional. So we need the bundle RPC and the token address, yes, token address, which we don't have yet. So let's make it. So content token address, and we'll sponsor the gas with a test token called CTT, which we actually just like did on testnet. It doesn't have any value. I'll take the account and I'll fund it with the specific token. User, do we still have a few minutes before we wrap up this workshop?
Yeah, it's okay. I think you can take a bit more time. It's fine.
Great. All right, let's find it out. Let's see if it's gonna work actually, because maybe the same paymaster, and maybe the paymaster is really out of funds. Yeah, because someone needs to pay for the ETH, right? So let's see if it's gonna work. And if not, then we'll have to bring the developers on Candide Discord and tell them how to fund this paymaster that is out of gas. So let's give it some CTT. So if you don't know where to get CTT, you just come on our Discord and we'll send you some, and you can try it out. It's just a dummy ERC20 token. We'll fund it with a half, and let's see where we're gonna go with it. Everything is quite slow, maybe because I'm sharing my screen and video and everything. All right, we just send the CTT to our safe account. So if we go here, we should receive it in a few, maybe seconds or minutes. We'll see it under token transfers. And then lastly, I just need to have the token address. What is the token address of the CTT? Oh, we received it. No, not yet. What is the token address? If you go to our docs, we'll actually find it. So let's go to paymaster token supported. And then we'll go to testnet, Sepolia, and this is the Candide test token address. All right. Now we should have it ready to be paid with ERC20 token. Let's see if the account received the token or not. Here we go. We have now the account is funded with 0.5 CTT. All right, let's see. So remember the balance here, 0.27. And let's execute this code. One last thing. We actually need an endpoint. So this endpoint is actually for gasless. So we'll go on our dashboard to get the token paymaster. So I went to dashboard here from the docs. And this is the Candide dashboard, and you can get an API key directly for the paymaster. I already created one, and you can just I have here the network Sepolia. Okay, good. View details, paymaster, Sepolia. Here we go. I just copied. Here we go. Now we can run this code and let's see what's gonna happen. All right, account address. Good. Okay, we got the same error, of course. Paymaster deposit video because it is the same paymaster indeed, and it's out of funds. So what we're gonna do, I actually did show you how to do gasless transaction and create token paymaster. This error, you just need to we'll ping the developers on Discord, tell them, hey, fund the paymaster, and it should work out of the box from there. That's it. I hope you enjoyed this workshop. If you do have questions, this is the time. You can ask anything you'd like. What we did not cover, you can take it next step, is that you can use passkeys, which is instead of using the private and public key address that we did use, you can use a different cryptography scheme, and you can use Touch ID instead. You can enable account recovery, which we didn't cover in this workshop. You can have, like, let's say, an email recovery or friends and family recovery and so forth. You can do a multi-sig as well. This is the default, so you can have two signers, two private keys to sign one transaction and to validate it. If there's only one, it cannot go through. And yeah, so these are the possibilities that are endless for smart wallets. Our Discord is open, so you can join if you have questions. We're happy to. We're also on the Telegram of the hackathon. We'll also post a hackathon guide, and we'll update everything in there. I did promise in the beginning of this workshop that we're going to use the new entry point. So we might not have it ready today, but tomorrow you'll have it ready. So if you want to experience with the latest account abstraction standard, you can do so starting tomorrow. Other than this, if you have questions, happy to answer. Thank you, Raul. Thank you, Saif. Happy to have you in the chat.
Amazing.
And yes, is there anyone
Sorry,
on
no,
YouTube?
Mark. Yeah, I don't think so, but we had a few viewers on Twitter as well, so I'll have a look at that later and I'll ping you if there were any questions there. But yeah, thank you so much, Mark, for the workshop. It was really cool. Really interesting, actually. The hands-on stuff was really interesting, even for me. Um, but yeah, guys, if you want to build using Candide tools, all the resources are on the DoraHacks as well. And if you want to learn about the Candide Labs Special Prize for the best use of Candide, then that's also on the DoraHacks. You can see that on the bounties page. Um, Amazing. If you guys have any questions, like Mark said, please ping us in the Telegram group. I'll add the Discord channel as well in the resources section, so you can reach out there if you have any specific developer questions. Amazing. I think that's it. I think we're done there. Yeah.
Awesome. Thanks a lot,
Awesome.
Uzair, and thanks a lot everyone who joined.